Right, welcome everybody. How's it going? How's it going? How we doing? So, today we're going to be doing some more ray tracing. Against the BVH this time. But we want to quickly just debug an issue with the BVH viewer and maybe just see if there's any big issues with the BVH. So we've got these two sliders here. This one allows us to select the level. Notice they're all colored the same. So there's two nodes on the first level, left and right. There's 4 nodes on the level below that. 8, 16, 32, 64, right, and so on until you reach the end. But it's kind of hard to see some of them. And this one here shows an individual node. We might need to add some other UI things here so we can traverse it easier. There was one, I don't know where it is, but we found it last stream. There was one of these that was very hard to see. Where is it? Yes, there's this bug here where it's sort of like half drawn, right? And I want to try and fix that because it shouldn't be half drawn. Hey there, Kraz. Yeah, the invisible one as well. Yeah, there's many invisible ones. Trying to find where the bug is obvious. We could look at the code though, but it's weird. Hey there, Rohan, welcome back. So yeah, we're just ray tracing, we're trying to see if we can ray trace a bunch of spheres really quickly. So we've currently built a BVH. But yeah, so we've been messing around. We've tried to bin them per tile. So this is how they're currently rendered, is through binning them into screen tiles, and then just getting a small list of spheres per screen tile and just going over those per pixel. But it's got issues. So we're currently building a BVH. I'm going to traverse that instead and ray trace that and replace that renderer and just see how it compares to it, because then it can be accelerated in with more than one camera basically, so we can do like shadows and lights and stuff with different views with the same acceleration structure. But yeah, hopefully as well it just gives it more of a, well, yeah, I'm hoping this speed is better as well, but we'll see about that. Does it disappear when you... No, it doesn't. I swear it's one of these guys. Let's look at the layers. Yeah, might be better this view, you see the layers. Weird. Like, what's happening to that ray? I don't know. Like, it's as if when you shoot a ray there, it gets blocked by something here. there might be an if statement actually that's blocking it. They're saying, oh, you've gone far enough to just stop. It's probably something like that. Kept paying, did you ever cap the distance of the objects to the camera? Yeah, I have. So if I hold the back key down, it'll stop there, basically. So I think that's the tiler, because it tries to tile them. Yeah, I'm not quite sure though. It might be. Yes, or something when it gets to near the... Or there might be a divide by 0 actually happening. I don't know. We'll see. But yeah, I've just minimized the issue by simply not allowing anything close to the camera yet. But also, I should really have a near plane where I stop anything rendering that close to the camera. Should probably sort that out. But yeah, welcome. How you guys doing? So this is the code that views the BVH. So let's just check if there's any sort of like possible if statements that could be blocking it. I remember we saw one last time when we tried it and it didn't. And it seemed fine. But yeah, there's these sort of like, so if this is hitting the left-hand side. Let's get Milton up so we can all easily just point to a tree whenever we're debugging these things. Yeah, it's just a binary tree. It's a binary heap, so it's all implicit. So we look at the left side and we see we've hit that. Yeah, this means we've hit it. And then this means we've hit one of the edges. But, right. Yeah, so checking for the front will make first will make sense. Yeah, so I don't think there's anything wrong with this code per se, because it's just saying it's allowed to hit set it up, and it's already checked to see if it's closer. So let's just double check that on the right hand side, which is just a copy paste because it's just been easier to work that way, and it's just debug code anyway. Right, I wonder if that depth could be wrong. This could be wrong. So 0, 1, 2, 3, 4. So let's just say if we take 3 for example, it's doing a 3 plus 1 is 4. Then basically get the convert into like a log2, right? Log2 form, so that will just be, so it finds the most significant set bit. So if you've got 4, that's 1, 0, 0, right? 2 is 1, 0, and 1 is just 1, right? So you'll get an index of, you'll get 2. You'll get 2 back, right? 0, 1, 2. So 0, 1, 2. That makes sense. So that was for 3. Yeah, that makes sense. The depth thing is fine. Oh, that will I don't think that will cause the problem though. We'll put things in the wrong depth. It kind of look fine. It's kind of the drawing though. So we do this sort of hit left. If you hit the left and the right hand side at the same time, it could be something to do with a stack. there was this if statement we removed. This one, so essentially there's a stack where if you traverse down the left-hand side, right? Or, sorry, if you've hit both the left and the right, because we checked the, these two are next to each other in memory, so we sort of check them both at the same time. If you hit the left and hit the right bounding box, we'll put this one off in a list, and we'll come back to it later, and we'll just traverse down the left and do the same thing again, right? Until we don't hit anything, and then we look back in this list, and then we can sort of just jump back to here and start checking its children, right? So I think let's just look at that code and make sure that's fine. BVH reminds me of machine epsilon and floating point nums. AT&T game dev, this is super interesting. Awesome. Yeah. You do use a lot of floating points everywhere, and it's yeah, it is a lot of fun. The best thing about doing this sort of stuff is you basically visually see what you do, and you sort of sort of like eye candy in a way, right? So so it's very it's very nice to see the things you do actually be this interesting thing, which is visual, right? Yeah. Although the programming environment for GPUs is absolutely terrible, but just the way it is, I guess. Yeah, so we basically said hit the left and you hit the right, and there is some form of child for the right one. We'll back it up on the stack, right? And we put this min element t on there as well. That's only for the right hand side. Forget about it. Oh yeah, it's only for the right. That's what we need. Because it's just where's the closest hit for this? Yeah, definitely an optimization. I don't know if we should have that for this. Anyway, so put that on the stack. This is all fine. So if we basically don't hit anything, we see if we got anything on the stack, and we take off the top of the stack, and there's this check here where we say if this is closer than the closest hit, we'll we'll break. But I'm just gonna let it break anyway again. I swear we tried this, but I just want to try it again, because it feels like it's the only place where it could be the problem. Why not get NeoVim on Windows? I'm not sure what you mean. Well, I'm not sure where the question came from, to be fair, but yeah. I don't use NeoVim on Windows though, because it's kind of, I've got a custom config and it depends on stuff. And a lot of extensions depend on stuff that comes from basically you should be on like a probably like a Mac or a it hates the whole command prompt stuff. And it basically just errors out on Windows a lot of the extensions that you use. Yeah. It's another reason why Vim kind of sucks, or NeoVim kind of sucks. That's so weird. I can't see why that's happening. See, I feel like if we can't get this BVH thing to work, this visualizer to work, okay, here's what we're going to do. We're going to render the faces, right? We're just going to render all the faces, and we should be able to see the problem, I reckon. Yeah. So let's put that back. So we're just going to render it as if there's a bunch of faces everywhere. Oh, and also I've put my keyboard away. I put my keyboard I have been using away, the Mac keyboard, and I've got back out the mechanical keyboard again. So I know people are going to be happy about that. I can't really lift it up because it's kind of restricted with the cabling, but yeah, mechanical keyboard is back. Sally, have you tried Kakun? No, I've not tried Kakun. Is it any good? I've heard of it about it though. Yeah, I use the cherry reds as well. Look at it. Of course, it's got Clippy. Funny. But yeah, it's like a modal editor. This is what I like, right? Too many people make new editors nowadays, and they're not modal, and it's like, why are you bothering making a text editor? Like, I feel like the modal editor space hasn't really got that much competition, basically. Yeah. Yeah, I kind of came off my mechanical keyboard because I was getting sort of like wrist issues, but so I went back onto the Mac one to sort of like, and I did my exercises and got my hands back to be feeling okay. But yeah, I've been playing about with it the past couple of days at work while I've been programming on my keyboard. Is like, how can I set it up so my wrist pain is fine? So I've got like this part came with a keyboard, and this thing I already had, and I can sort of rest them on here, and I can just rest my wrists sort of on there when I'm programming it. They're nice and well rested, but I have to move it away from the keyboard. The problem is I had it too close to like the keyboard, and my wrist was still sort of like holding themselves up basically. So I've sorted that bit out now. So it should hopefully be something I can stick with because it does feel really nice to program on the mechanical keyboard. Like, just feels joyful when you press the keys, So pretty nice. So if we disable these, what we should be able to do, well, what I want to do is have something like that. So we'll just say, oh wait a minute. Oh no, my mistake. This is not right. Yeah, we don't want to comment all of this out. Right. So we'll just do this whole if statement again, but without these, including these and something like that. And the closest hit depth would be tmin element. All right, jobs are good. I think, or maybe we could just say hit depth. And that way we can just keep it there. Share the code. So that's for the right hand side. We need to repeat that for the left hand side. Let's just do that quick. Oh, sorry, that's the left hand side. Right, so that's gonna not do this sort of like, have we hit the edges of the bounding box? We should just see it fully colored in. And so let's just analyze that and see what it looks like. Try using a wooden rest or use a low profile mechanical keyboard. Yeah. Unfortunately, yeah, I need to change that. Okay. So, yeah, it's a prime example right there. Look at that. That's not what we want. Like, why is that? We can actually do an if state. We can actually put some printfs in here and get it to come back. You know, we could be like, oh, the pixel in the center of the screen and just sort of see what the problem is. We could do that, but it's very strange. So, like, you must be hitting that, right? So the thing we're going to test now is, all right. Let's see the. We write out here, right? So it just means this thing must not be set, right? And the only place we're hitting this. So you know what we should also do? We should have buttons, which allows us to go up to the parent and see sort of the parent bounding box of this, and just see what that looks like, and maybe that there's a pattern there. So we open up our. We've got a little debug UI at the moment. Right here, so we're gonna add some new things like buttons. So let's make a new box. Let's call it B. Keep cutting left. So we want to do like a button with some text. Button with some text, we need a rectangle, so we'll call it C. And we just need some text, so the text is going to be parent. Let me say C, don't know, yeah, good. If. So what do we get back? Isn't it like a focus state or something? Oh, it's been pressed. Alright, so it's just a boolean. So if you press this, we want to make sure we move up that node index thing. So you say that equals, I think I called it like BVH parent. So it's just a binary heap, so you can just use maths to work out the parent. So we can have things for like, you know, child left, and make sure we do another cut. Child left, and do another one for like child right. What other traversals is there? It's just, isn't it? What else might you want to do? I think that's all we need. Hey, Roydell. I wonder how big of a difference the workload is for shader units in between rasterization and ray tracing. I guess most of the work for ray tracing is traversal, which might be done by dedicated units. And how much then? Yeah, I don't know. I think that varies from hardware to hardware, but from what I understand, they probably just use compute shaders anyway, or compute units. I think, if anything, they have dedicated hardware to do like a dedicated instruction or something to do like a triangle, a reverse triangle, or a sort of a reverse axis line bounding box or something. I'm not quite sure how much sort of like or they might have special hardware where the BVH sits in memory or something, right? Sort of a dedicated cache or something. I kind of doubt they have a whole special sort of like compute processor, right? that just does traversal. But yeah, we'll see. Yeah, I'm not kind of sure though. But yeah, the APIs, like the ray tracing APIs that we're not using, have right. It's not being alpha blended. Nice. Oh, it's the tile. It's the tiling. Right. Okay, the tile. Okay, so the alpha blending is kind of broken on the UI, which is fine. Doesn't matter. All right. See if that's good enough. Okay, so we've got these buttons now. So we should just be able to go, oh yeah, go to the parent, right? Now with the parent, you can't see all of this in it, right? Go to the parent of that. It's this guy, okay? Which is our root. Oops, over the end. So left, 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 left. Maybe not. So there must be a right in there. So if we go to right, left, left. Interesting. Parent, right. Okay. Okay. So we're seeing this thing here where both of these have the same problem. The left and the right have the same problem. But it's only when we've gone down to the right. Okay, should we go down to the left nodes and see if any of these guys have the problem? I don't think they do. So it could be to do with the right traversal again. Like, I'm not sure. So we'll go down the left, left, right, right, right. That's fine. Let's go left again. Yeah. So I think it's to do with that initial right. Something to do with that initial right. Was the whole thing fair play? See, and then that one's cut off. It's super weird. So what about its left nodes? Like, to me, like that one is this guy. Right, okay. I'm seeing what's happening now. Okay, so you've got, let's see if we can draw this up so it's a little bit more. Sibling left and sibling right. Oh yeah, that's the other way, that's the other buttons I was thinking about. That's it. That's a good point. See, I thought about this off stream and I was like, oh, we need these buttons. And I thought of 5, and then I couldn't remember the other 2. Thank you. Yeah. So the problem is, as we're seeing from here, so we're starting off with the root. This left one, right, seems to be cutting out on the right's children, right? And it could be the jumping code that we've got. This super awesome jumping code. So this one here, this shape here, is cutting out on these 2 children's shapes in the visualizer. So basically, and these are way too big, these buttons, but oh well. Go to the shader. Yeah, some do this jumping code, I reckon. So we give you the index of the left child of the right. Okay, so the right one, let's go up here. So we start off in our, and our next BVH index is the left-hand side, and the right-hand side is just 1 plus that, right? So when we do the right-hand side check, or left-hand side check, the right-hand side check, and then we get down to here to see if we've hit the left or the right. If we've hit the left, we calculate the next BVH index. Yes, that doesn't get used anywhere else, that's fine. And then we say, hey, if we hit the right and it has a left child, then, or if it has any children, right? We basically just back up the left child on there, right? This seems all sensible to me. I'm not sure what's going on. So, right, this all seems fine. Because you would have hit that left and the right. So it would have hit. So you would have hit a lot of them though, that's the thing. That's the crazy thing. But it's just when it gets up, you know, it's kind of out the whole blocking it. It's as if we've run out of the stack. Maybe. I'm not sure if we could have overflown. We could have maybe overflown it. We could have. No, we couldn't have overflown it. Because the stack is like 32, and that's a 32 depth, which is 4 billion spheres, which haven't got 4 billion spheres, you see. So we've got a big enough stack to kind of back up these child indices. So you're backing up the left-hand side of your right, and you'll come back to it. So, you know, if we go out of bounds, say while we have something on the stack, retrieve it, and then we'll break. So we did comment this out, and it didn't fix anything. So it's nothing to do with that. It's just saying make sure it's closer than the closest hit. Let's comment it out though. It could still get in the way. We're getting close though. We've got an idea of what it is, but it's just how. The thing is, it is the first. It's the only one that ever happens, right? It's the only type of cutout that ever happens. These ones are fully getting cut out, probably because they're from the right-hand side. So I feel like maybe the first element is not getting visited again. But it has to be. Yeah, because I'll just up it to 1. And you say, you know, be 1, then you go back to 0. You pull it out, break. And then this b equals 0 is running equal false. That's the problem, innit? So you need to allow it to run 1. Right, so really, you only want this is running false What's happened there? Right. Okay. That'll fix it. So you go down to the right, go to the left. And look at them, they're all showing now. Would you look at that? So now we can just bring back the actual bordered hits. So we just see a border and voila. Oh yeah, we're in business. So, should we increase the yeah. Okay. Yeah, so that's like the huh. Yeah, so it's getting 4 in there. Could have swore we only had 2. Yeah, I thought the root only had 2 spheres, but I think you've got 2 boxes that overlap in some way. Yeah. Yeah, I think there's definitely ways to optimize this. So what we're going to do now, since we found that problem, is we're actually just going to ray trace against this, and it should just be fine. We hope at least. But I think there's ways that we can optimize how these are bundled together, because if you look at it, there's probably quite a lot of like overlap between the layers. So here's level 1. So this is the left and right, and as you can see, they sort of like, you know, the other box is inside the other one. It would kind of be nice if there was a perfect, somewhat of a division where there's a bit of an overlap on some dimension, right? Maybe it's in the... Yeah, maybe I need to change the building code a bit to sort that problem out. I think that was what was addressed in this blog. There's this sort of like find there's this sort of code here where it finds the split. But yeah, we'll think about it. But it was a little bit more complicated, so I just skipped doing this. I just made a binary heap instead. But yeah, we'll see. Maybe there's a way to order the nodes when we generate it to sort of make this problem go away. But yeah, as you go down the levels, see, one of the boxes still covers the whole thing, and the other ones cover a smaller subsection. But then you go down and they break down even more now, and this is much better. But yeah. For some reason, these don't show up as being in one, and I don't know why that is. Yeah, so something might not render. Then this left-hand side might not render, but that's fine. We'll just fix it when we comes the problem. We will keep the old renderer as well while we're making this transition. Okay. So what we're going to do is we're going to find that we've got this like sphere ray tracer. We're going to take this and we're going to call it sphere ray tracer tiled, right? And give it a rename. But just copy paste this one. This is with the tiles basically. So this new one is going to be, it's going to be like the BVH viewer in a lot of ways. Would we need the debug level? Yeah, we'll bring in the debug level stuff because that way we can write the code that's will ignore the spheres that are not inside of those sort of levels or something like that. so we can really debug it further. But yeah, so we should be able to get rid of these. Basically, jobs are good. So I just want to find. Okay. So let's copy paste this one. So we'll essentially have like an if, right, and then we'll else it. Like that. And so this will be the tiled one. Right. So that's got to be using. So go to the shader. We'll put this under here like that, and we'll call this one tiled. So that's our old one, which works on screen tiles, which we will get rid of in the future. So, okay. So let's go and get this. Make sure we've got all the right fields filled in. So we're output dims. We've got a BVH. Wait a minute. Where's my spheres? We need the array of spheres as well. And we probably need a spheres count. Because the BVH is going to reference the spheres on the leaf nodes. So we probably just want to make sure. So fine. So let's copy all these again. All right. So we've got output. We need spheres. Bring the spheres buffer. We need BVH nodes. BVH nodes. So that's the BVH nodes buffer, which is filled in on the GPU. Then we need the BVH nodes count. So that's all in here. We also need the spheres count. Cool. So now we just need to do some sync code just to make sure that it's all synchronized and we don't have two shaders running at the same time. So we need the surface, the display surface that we're rendering to, and then we also need to put in obviously the BVH nodes and the spheres buffer, and they're read-only. Okay. So that should be everything we need. Yeah, so let's get into the shader now. Should we try and launch the old one and just make sure that works? What does that say? An unused or something? Oh, okay. It's saying pointer's not supported. Yeah, because I didn't say it's a compute shader. So we'll just do 8x8, right? Something like that. So, right. Hopefully this doesn't crash. Right, okay. So the old system still runs. So what's interesting to note is compared, so the BVH viewer is doing more work than the ray tracer should be doing, I think. We'll see how it ends up. But it's actually a lot slower than the tiled renderer for this particular case, for a very small amount of spheres. But I wonder what will happen when we add loads more spheres and when we're not using this sort of BVH viewer, because this one does more work, right? It tries to collide against all the edges going down the whole tree, whereas we just need a very simple traversal. The complication will be in the sphere ray tracing when we hit the sphere, but yeah, we want a simple bounding box collision. So we should be able to just copy the whole BVH view and then just edit that. But we'll talk about the code though, because it will need changes. So we basically have a fixed camera right now. You know, I think as soon as we've got this stuff all hooked up, I think it would be good to get the camera plugged in so we can at least move the camera around and have code that just works with that, right? It'll kind of suck if we write tons and tons of code and then we have to edit in tons of places the camera stuff, right? So yeah, we should get that sorted out sooner rather than later, really. Also, there's no such thing as wait a minute. Yeah, also the things we're ray tracing against, like the BVH in the world. Yeah, it's kind of positioned in world space, so we don't sort of go into local space of this BVH object yet, and that's something we should probably move over to pretty soon after we have this thing in. Yeah. So we basically just launch this over the whole screen. So each pixel gets each thread gets a pixel, and each pixel is a ray. Is one ray. So we just sort of calculate the ray direction, and we basically calculate the inverse ray direction. So we can multiply instead of do a more expensive operation, right? So again, the whole sort of like, yeah, so this just works out the pixel size at the near clip plane. We probably won't need this, so I'm just going to delete it. Yeah. Oh, and also, we have like a fixed field of view as well. We should sort that out at some point. But yeah. Oh, we need the field of view. Where did that go? Yeah, let's get rid of this stuff. We don't really need a pixel size at a near clip plane anymore, because we used to sort of see, you know, if we've hit something in the world, is it like, is the distance like a pixel size? If so, do some certain logic, but I don't think we'll need it for this. I was thinking maybe we could do something with like selecting like a LOD or something in the future based on that, but we'll see about that when we get to it. So we've got this sort of like previous hit stack for the right hand side of the tree, right? We can always traverse back up to the right hand side if we hit both the left and the right. And yeah, we initialize our closest hit stuff to like the max values, right? And we're just going to loop. And every time we loop, we basically get an index to the left hand side. And the right hand side is just 1 plus that, because it's a binary heap. So we skip the root node purely because it's just a single node, and I want to kind of write code where we check 2 nodes at the same time. Well, no, they're not at the same time, but they could be in the future. So by doing this, it means we can check 2 at a time. 2 every loop, basically. So I was thinking maybe a pixel gets 2 threads, right? In the future, so possibly we could do, you know, like an odd and even thread get the left or right node to check. And so yeah, I think we should probably play around with that at some point too. So yeah, we get the left hand side. So here's all this extra code that we basically don't need. So this just does a simple ABB versus ray check, and we'll see how much of this we actually need, right? So So let's just start removing code, right? So this is where you know if you've hit the box. So literally all we need to do is just delete all this. And we can basically just say, hey, the closest hit depth. See, this isn't really the closest hit depth because those closest hit depths should actually be the spheres that we're ray tracing against and not the boxes, right? Because this came from the BVH viewer and that was all about hitting the boxes, but it's not the case anymore. So this could probably be simplified even more, but let's just, yeah, okay, let's just look at it. So it all depends on what we really care about, because this cares about if we, yeah, so this checks to see, yeah, I think this is what we want. Yeah, this one makes sure that the box isn't fully behind us. Behind the ray, and it means it's in front of it. Yeah, this one just makes sure that it's not. Yeah. Yeah, I'm not sure how much more we can simplify this, to be fair. Maybe we need that. Right, let's just carry on. So this right-hand side one, we can just get rid of all this code as we did earlier. Like that. Okay. Yeah, so I wonder if it's really worth running 2 threads per array. Not sure if it's worth it, but maybe so. NeoVim or Emacs? I'm using NeoVim. It's okay. It's alright. It's about like a B, you know. About B minus. Like, yeah. But I keep getting a mention to look at Cocoon from Sully. So maybe I'll look into Cocoon, but I don't know. It could be very similar. Yeah, Vim over NeoVim. Yeah, I can kind of agree with that. Was using NeoVim. Sorry, I was using Vim before. And I switched over to NeoVim because, you know, there's all the hype around it. But my config back used to just be very sort of Vim-like, not have much of the new stuff, right? But then, you know, people using all of these sort of like extensions and that, so I'm trying them out now. But it has made the editor slower. But this is Cocoon here that we're looking at. This is not NeoVim. But yeah, I'm just looking at Cocoon. No, it looks kind of ugly, this theme, not gonna lie. Not very appetizing, but that one looks better, but still not the best. Yeah, it's definitely slower though, with all these like all the features the cool kids are using, and so it kind of just feels like using Visual Studio Code, right? What's S tier to me? Or for an editor? Well, you know, part of the problem with Vim as well is you've just got a whole config file, which is basically a whole scripting language. It's like, why is this thing so complicated? Like, why can't it just be a config file? You know, just a bunch of variables that you just set. Because basically it's a solution which solves 2 problems, right? It allows the user to extend the editor and configure it in the same place. So rather than having plugins and configuration separate, they're sort of combined. And I feel that's a bit of a weird user experience, like using NeoVim and Vim for that case. But the thing that makes NeoVim and Vim the best is the fact that it's got the modal editor, right? And if it didn't have that, it would kind of be pretty lame. right? But that's what makes it shine. But oh, and it used to just be like really quick, as I said, but now you've got these extensions everywhere. It's kind of like, you know, a bit meh. Yeah, so we hit the left-hand side. Yeah, this is the same code as we saw earlier, right? So we hit the left-hand side. We'll start traversing down the left-hand side of the binary tree, right? But if we hit the right-hand side as well, we'll back it up, right? And then if we hit the right-hand side, we'll just go down the right-hand sides, or the left-hand side of the right-hand side, right? And then if we haven't hit any of them, we'll just end it here. Well, we'll say we haven't hit any and we'll try and traverse back up the stack, but if there's nothing on the stack, we'll bail, right? And this one writes a pixel out if there's a closest hit, right? So we haven't actually done any checking for the spheres now, right? So the thing is, so you hit left, you hit right, then you go down, right? So at this point, we need to kind of check to see if this node is the leaf node. And then we need to work out, so where's the assigning code again? We do that sort of build. Yeah, BVH count bounds. This is where we build the BVH on the GPU, right? It's got all the secret source. So essentially we assign 2 spheres to every leaf node. So we just need to work out the leaf node index. And then from that, we can calculate the sphere index, right? Or the 2 spheres we need to check against. And we'll pull the spheres out and just ray trace against those. And then boom. So that's what we need to find out. So we need that number, or that variable. And then we probably could just do that as well. Okay. So all we have to do is say, right, if BVH left index, so this is the sort of the base node index for all the leaf nodes. So you have a binary tree like this, it has 7 nodes, right? And then these leaf nodes have 2 spheres each. Well, they don't have to have 2 spheres, they could actually have 1 less at the end, but anyway. So to calculate the base leaf node index, is just the number of nodes, take 1 divided by 2, right? Is that right? Huh? What? That feels wrong to me now. I swear we had it as a problem and we fixed it. Yeah, something's up now, because I remember when I was building the BVH code, we fixed a problem, and it was to do with this, but I don't know, we just broken it again. So, you got, 4 plus 3 is 7, right? So if we did 7... Oh, no, it's fine. That's right, that's right. Yeah, that's right. So it's 7, right? Take away 1 is 6, right? Divided by 2, there's your... Yeah, that's your leaf node base index. So effectively, if this is less than or equal to the left, then we can start ray tracing at some spheres. So we need to calculate this guy here, which is the leaf node index. So we just do left take space. And then from here we can work out our base spheres index, and then just look at the two spheres, ray trace against those, and see if we've hit those. Yeah. Okay. That'll work. Yeah, so there's a bit of a weird problem where we don't really pad the buffer out with just spheres that won't be a hit. And we kind of like need an if statement, so I really need to get rid of that at some point because it's kind of dumb. Right, so we just want to get our two spheres and just do a check against those. So should we go to the old sphere ray tracing code and just grab that and just see. So there's a function here called ray3d verse sphere, and we've got this sort of like anti-aliasing stuff in here as well, but we've kind of proven that, well, I don't know, we kind of want a good, this is interesting. What do we want to do? We should probably have similar code so we can see how fast it is. Yeah, let's get it. Right, so we need to fit in all these parameters, and we probably need a for loop now. So we'll just say something like for base spheres index, and then we'll say something like index less than base spheres index +2, and we'll probably min it with BC spheres count. So we'll stop it from going off the end of the array. So we'll loop over it twice, grab ourselves a sphere, and we'll start doing our checks. Okay. So Raver sphere, it takes in these parameters here. We've got this guy. I've actually got the inverse of it, which is kind of better. So looking at this, I don't know. Okay, we don't actually need the inverse of it ever. Interesting. Fair play. Okay, so we've got that already. We just need this sort of ray t min and t max. So this is just effectively saying like, where's our near and far plane? You know, what's the near and far distance? It's not really a plane though. But yeah. So let's just get these at least. So put them in there. And then we'll S, which is the sphere, which will get passed in, and we'll do a reverse sphere there. So if we have a hit, we see if it's closer than our closest hit depth. If so, we update it. We've also got a normal in there as well. So we kind of back this up to do the coloring of it later. I'm not sure how much performance it really netted us in the end. But anyway, let's take a lot of this stuff here. Hey there, Oak Spirit. No, not at all. Right. Let's see how this goes. So then if we didn't hit, we see if we've if we're like a pixel out. So I kind of need that pixel at depth code back. I don't know why I deleted it. Pixel size at near plane. Let's bring it back. So let's just put that back at the top. Yeah, this does some anti-aliasing basically. Yeah. It's alright. Yes, this finds like the closest near miss. And yeah. It allows us to anti-alias. But it's not great because you could actually get 2 near misses. And this code sort of keeps track of the closest one. We'll see. We'll see how this goes. There's stuff to sort of iron out. Okay. Getting close now. So the final thing we have to do is we have to actually color the sphere in at the end. So here's the old ray tracing code. If we found a hit, right, we'll basically do this code here. So copy paste it. Yeah, there's a lot of stuff to optimize with this, but it's fine for now. And clean up just in general. So we found a hit. We'll calculate the sphere color based on the normal. This code changes. At the moment, we basically just color. We've got a bunch of different options that we're trying out. So we just basically color it in with the normal. So we just get something where it lights up the whole sphere. But we can do different lighting. We've got some sort of basic test lighting in, where it just does a light from sort of behind the camera going onto the scene. Yeah, this one just does the base color that you provide. Hey, not so red. Not doing bad, not doing bad. Just a little bit tired. But yeah, doing pretty good other than that. We found a bug in the BVH viewer. So we fixed that. We're just putting together a ray tracer using the BVH structure. So we're just seeing how that's going to turn out, really. But yeah, how's things going? Yeah, how's work going? Yeah, so this is where it does the sort of blending with the near miss. We say, oh, if the near miss is closer than the closest hit, right? So if we've got a sphere in front of a sphere that we actually hit, and we sort of, the ray near missed it, then we want to sort of blend the two colors together based on how far away the ray is from the near miss, right? And that's doing the alpha blending. Sorry, that's doing the anti-aliasing. And then we blend the pixels as if it was like alpha blended, right? And then we just put the pixel to the screen, basically. So that should be it. We just gotta get it compiling, and then we'll check over the code because it could, you know, blow up the computer. So we want to make sure it's all gonna work before we do any of that. There's nothing called hit right. Is there? Oh, it's inside an if statement. Right, so there's some code that we've missed out on. Yeah, we need to make sure that we set our next BVH index to outside of that. Outside the boundary of the BVH node array, so it can then start going back up the list and just be like, oh, is there any ones that I've missed? You know, you can start looking at the stack of the previous hit stack and start looking at those guys instead. Right, any more? Color. Nothing called color apparently. It's fine, we can make a color. Okay, all compiles. Which means it's guaranteed to work first time. Doing good too. Worked in the office today, so I'm a bit tired. Fair play. Fair play. You, yeah. But, yeah, how's you getting into the swing of things at work now? Are you being trusted to do more stuff in the code base? Yeah, I feel you, man. Sleep is good. I'm already so tired for some reason. I don't know why. Yeah. Oh, maybe she got another tea. But anyway. Yeah, so we get the pixel coordinate, the ray tracing, cameras fixed, get the ray direction, blah blah blah. Pixel size at near clip plane, which is useful to sort of project that out into the world and then sort of see how big a pixel is at this distance, right? And which is useful. This is our ray min and max. We have a near clip plane, but we don't have a far clip plane. A bunch of setup stuff for the loop. We've got like a closest hit. We've got like a near miss start thing. We've got like a stack of previous hit nodes that we couldn't quite traverse because we hit the left and the right node at the same time. We start on the children because we ignore the root, because the root only has one and we check 2 at a time. That sort of thing. So we go down the BVH and we go, oh, so we get the left and right node. Oh, we only check the left. Wait a minute. No, we're on, sorry. Yeah, that's fine. Right, we would have, no, we check into at a time. Wait, no. Yeah, you'll be checking 2 nodes, of which will both be leaves. No? Wait, yes, so something's wrong with this. So you would have hit the left. Oh, no, you wouldn't have. Yeah. You'd have got here, you'd have checked this node, and you'd be like, this guy is a leaf node. So base leaf node, yeah, you say this one is a leaf node. Yeah, so you'd actually be checking both the left and the right. So this code does it wrong. You actually want to repeat this twice. So you actually want to do 4 of them, right? Check the next 4 spheres. Do you? Nah, see, this is silly. We should have done the, yeah, no, this isn't right, Not right. So you should check if you've hit this node, and if you have hit this node, then check these 2. So it needs to kind of go in here, and then you're sort of repeating all this code. It's going to get repeated. Even if we put it in a function, it'll just get inlined. So part of me is thinking this probably could, it might be better with, yeah, it might be better with doing that 2-thread thing that I was thinking about. Part of me really wants to do that, but probably not the best thing to do right now. So I guess we'll just copy paste it. Yes, if you hit left, and you want to say if left Oh, isn't this lovely code? Oh. Yeah, let's just do all that. Let's just copy paste it. I love where we made that code far more simple. And then we just made it more complicated now. Yay. Let's bring these all in. There's some Rust level indentation. Hey. Hey, LCT, how you doing? Is it possible to see the current status of the game? Yeah, there's not much of a game at the moment. Currently, it's an engine without a game, even though it's called Game Van Engine. We're currently just doing some. Yeah, Yeah, you should be able to see it very soon. We're just doing some rendering R&D basically. So we're trying to see if there's some way we can sort of get some distinctive art style, basically. So just playing around with different techniques. We're trying to ray trace a whole bunch of spheres at the moment, and we're trying to see if we can ray trace them in a very, like, if we can do it quick enough. So that's what we're currently exploring. So we have a little test model and we're ray tracing against it. And we have a BVH as well that we've made. Yeah, I worked on a lot of stuff, but I still fully don't understand the code base. It's so much. It's too much. I'm getting there. Yeah, I know what you mean. Yeah, I remember it took me about 3 months when I joined the company I work at now. It took me 3 months to fully be like, you know what, I get this code base. You know, I get it now. Not to say that I wasn't capable of up to 3 months. I could still do things, but it's like in terms of if I could get asked to sort of do something, I could sort of navigate it and know the sort of general things that go on and that, and probably find out how to tackle a problem, right? Have you handled if you go over max stack count yet? No. Because it's kind of the maximum stack count is 32, which is 2 to the power of 32. So it's 4 billion spheres. But yeah, something we need to properly handle at some point. Because we probably want to maybe move it down to like 16 or something like that, and limit the amount of depth on the BVH. Something like that. Hey there, Nico. How's it going? How's things going? How you been? Oh, something's up with my braces, man. What have I done? Oh, it's too much indentation. Oh, that's right. That's okay. That one needs to be deleted and moved in. Jobs, good. So this needs to be edited here, this right one, because it's got references to the left. Bob's your uncle. The two spheres checks, and I've just inlined tons of code, horrible. But it's just a test. So this still works then. Same. Right, jobs are good. Lisp but at C, exactly. Yeah, we can do that. Done. Yeah, some people like doing that where they sort of like, they'll do a function call. Like if they break out a function call into a new line for some reason, they'll like end it like that, right? With the extra stuff here, but I typically like to sort of like put it back, you know, so you can sort of see it open and close. You know, so if you add more stuff, it's easier, and you know, you just whatever. But yeah, but it can get really funky if you have nested versions of that, and it all just ends on the end, just stuff, you know. Is this Bob guy? Oh no. Well, it's definitely not Uncle Bob, right? Or is it? Okay, so apparently that compiles. So just do one more check just to make sure, and then we'll give it a run and probably blow up the computer. So we're going left. You know, every time we hit here, we look at the left and right. Yeah, so just if we hit the left BVH, if we've hit it and we're a leaf node, we go over all the spheres, get the leaf. Left-hand side, leaf node index, calculate the base spheres index. Go over all your spheres, 2 spheres basically. Get the sphere, do the RAID check. This is all copy-pasted code, this will be fine. Right-hand side, do we hit the right-hand side? This is all fine. If we hit the right-hand side and we're a leaf node, get the base leaf node index, calculate the spheres, go over all the spheres, do the RAID check. Cool, that code's fine, we've checked it. This code's fine, we've checked it as well. Right, should be good. So, right, let's quickly show what it would look like for that viewer, Everman. This is what it used to look like. And it's still going to look the same. But we'll see. Should we put the T back in? Get a bit of wobble. Get a bit of wobbly. Right. So essentially we've got this like model, right, that we've made. We've essentially got like a 3D volume that we've like iterated over and just put spheres in there. And discarded spheres that went inside this sort of SDF shape. So we've just got 2 spheres on the left and like a like a 3D rectangle in the middle, a bit like a dumbbell. And we've just used that sort of SDF shape to discard all the spheres that are not in that shape. Then on the GPU, we go over all those spheres and basically produce a bounding volume hierarchy, which is just a tree. So you basically have like a tree of these boxes which help accelerate the ray tracing, right? And that's what we're viewing here. Blown up computers are experienced with that. Oh. How have you blown up some computers? Have you got any stories? I remember you also had like that server, isn't it? No. Am I misremembering? Maybe I'm misremembering. Right. So here's what we're gonna do. We're just gonna enable that new ray tracer. Loading kernel modules that panic the system immediately. Oh yeah. Yeah. What's the idea for the game? There is no idea yet. We're currently building a little foundation where we can sort of prototype within this engine. So we have a core foundation of enough to iterate on. So currently we're using that sort of core foundation to iterate on a art style, and we're trying to find something sort of unique because things typically are going towards realism nowadays, and it would just be interesting to see if there's something different that we can find. Someone's probably, with every cool idea that you've thought of, someone's probably done it already, but it's just interesting just to find it yourself, right? So we're just going to try and render a bunch of spheres to see if we can make that look nice. And also render fast enough. And then after that, and after we've found this sort of rendering style, we're then gonna do a design for a game and just really hone in on what this game is. So we'll probably have to prototype a ton of stuff, like we're doing now, where we just make a ton of mess right in the code base and just figure out sort of like what this thing needs to be. And then basically write it all down, have I think you should make like some, the typical ways to like make some pillars and try and find what the core of the game actually is and define it. And then just give me enough sort of, enough of a foundation where it's like this thing is stable, so I can basically forget about it and remember it, by reading what I've written. But it's not too much where I just forget, where it's just get overwhelmed. But also give me enough room to sort of like, while I'm making the game, make some decisions and evolve it while I'm making it, that sort of thing. Because I can imagine I have to work on some technology, and the worst thing is like really forgetting about the game, and then you come back and you're like, what was I making again? And you've just like, forgotten about it, and it's very easy just to abandon projects that way. As you shouldn't be debugging stuff in the live system you're working on. Yeah, that happens. Or yeah, and tinkering with like a system you work on as well, another one. Like when you do graphics test code while streaming, that can hang the GPU. Yeah, exactly that sort of stuff. Exactly. You just explained why you should use a game engine. Not really. That's not really any... Like, if I use a game engine, I could probably prototype something in it. But, like, it's in a completely different tool set. And I probably like hate my life more. Right? Because you lose sense of the game. That's not really it. You lose sense of the game when you have to sort of like, you just get, you'll lose sense of the game even if you use the game engine if you haven't really sort of like prototyped the game enough and found it and defined what it kind of is. Anyway. Right, so the stream could go down because AMD drivers suck on Linux and Windows. So the stream goes down, I'll be right back. But it should work. Right, so we're running our new shader. Let's go. Okay, so we're rendering, but we're only getting partial renders, which is a shame. This is funky. Like an optical illusion. I can only see it through some certain boxes. So Yeah. Interesting. Yep, gotta sync it. If not, I'll shut down my computer and it'll be like half written, and then like it'll files could be corrupted. Yeah, so you gotta sync that. Gotta sync it. Alright, so first thing we're gonna do is remove this. This is an optimization. It just basically means if we've traversed down the left-hand side, right, and we've not found anything, we need to go back up the stack and find a closest hit, it can jump to the nearest check on the right-hand side or something of the tree. But this is a little check here to say, hey, if it's further away than the closest hit, then don't render anything. If it's further away than the closest hit we've already found, then yeah, then skip it and go up the stack again, basically. Hmm. Oh shoot. I've just realized there's a big issue with this. It could have been an infinite loop. Could it? We could have gone into dodgy memory. Wait, no. Yeah, with this enabled, we could have had some. We'll have some problems where it would have checked it anyway. Yeah, no, it would have just checked it anyway. So really, what you want is that to be in there, and then you just do this check, and you just do this check right again. So we need to do that on the BVH viewer. But anywho, let's just go back. Right, so let's see if that gets us anything. Right, so that's not the problem. It does the, well, I think this is actually the right-hand side. Yeah. So if we keep going right, we see hits, but the lefts don't ever get hits for some reason. So the left's not really getting any hits. Um, hmm. Reorigin, redirection, team, and team max. That's fine. I wonder if I should add that debug stuff in. So we could target a very specific node. We could say, yeah, we've already got the debug stuff going in, isn't it? These debug level on node indices. So what we should do is we should say, hey, if yeah, if you've hit this node, basically debug something out, or debug print something out. So we just say, hey, if debug node, where is it? So if this one is equal to the BVH left index, then we just want to say hit sphere. So GPU hprintf hit sphere index, something like that, right? So we should see this most with two spheres printing at most per pixel. So for each pixel we'll see it, but yeah, we'll see how bad that gets. We can always move the object further away. So let's try that. Thank you. Yeah, it does look pretty cool though. Like the it's like got like an optical illusion to it, isn't it? Where you look at it from a different angle and you see more reveals. Right, so we haven't got, so we moved this slider, it's going to start telling us. No? Oh, yeah. This is a leaf node. Here. That's a leaf node apparently. There's no more children past that point. That's another child. And we're hitting two things there. Okay. So let's just go to the right hand side and see what we get. Ooh. Weird. Right, let's just go down the right, the left hand side. Right, there's no point where it pops up. So it's generally like not hitting like those at all. So why don't we bring these out a bit and just put it on like here to see if we actually hit the box at all. We actually traverse and actually hit the boxes, right? Hit BVH node. So we'll do something like that as well. Okay, so we, traverse down the left-hand side, right. We're getting like very slow FPS here. Right, tons of pixels are right out to that buffer. Let's make it really small. So clearly, we're hitting the box, right? That's not up for discussion, right? So we're hitting the box. So the question is then, are the spheres inside the box? They should be. But they might not be, right? So we're definitely hitting the box. I'm hitting that every frame. Well, yeah, if not, you see it flickering, right? So we definitely know we're hitting the box. The other question now. Well, sorry, we didn't know if we were a leaf node. Okay, sorry, that wasn't a good test. Let's do that again. So we traverse down the left. It's not the one I'm talking about. What? Wait a minute, why is the... Okay. Okay, so we're definitely going this far down. We're hitting it. I just don't know... So we should probably start printing out the sphere positions and also probably the bounding box positions as well. And that will probably be a good test. So for this case then, so you have A, B, B, min, min, max. So we'll literally just dump that all out and then we'll get the two spheres, dump those guys out as well. So we'll just go F. See, I don't really have good print support to do like, you know, proper printing, but anyway, this will do for now, I think. I could make it print out less information, but I think that's fine. Hopefully we don't exhaust the print buffer I've got. Should just be able to print out enough, I reckon. So we've got that, that's cool. Now we also want to print out the sphere that we're testing against, right? Oh my days, can you see the problem? I can see the problem already. Man. Base sphere index plus index. When we start off at base sphere index. So it's actually doing an out of bounds. That could have crashed the GPU. Should have crashed the GPU. But anyway, that's fixing the problem. Boom. It works. Look at that. So let's remove all the printing code. And okay. Oh yeah. So now let's take a look at how this is. So it's actually a tiny bit far. Yeah, it's about, I don't know. Yes, it's faster than the BVH viewer as we was expecting. It's not as fast as the sphere, so the screen binning yet. Yeah, the tile binning. We can't. We could actually run them both at the same time. There shouldn't be a problem with that. Well, not run at the same time, but Yeah, they should be able to run one after the other. I don't see an issue with that. We're just mutating the final buffer. Although, so if we're mutating the final buffer, yeah, we're not doing any blending, we're just writing a pixel out. Right. So, I don't know. Let's just see. Because we have them both run at the same time, we can actually judge performance and test it that way. Okay, so with the tiled one which runs before, it seems to be dramatically quicker. You know, our BVH one seems like really slow. Seems like, yeah, seems quite slow compared to the tiled binning. But we can make a change to that. We can start optimizing it now and try and make it better. Yeah, part of me really wants to try. Right, so let's just commit this because we're in a good place. Ray trace spheres using BVH. Nice achievement there. But yeah, we can definitely optimize this shader. It's not the best, right? You know, we're doing per iteration, we're checking the left-hand side, right? It's basically copy and pasted code. You know, you could be like, just put it in a function, but if you put it in a function, it gets inlined anyway, right? So it's a bit like just doing this. So kind of doing this makes it sort of see how ugly it is, right? So part of me is thinking, right, we just, like, we should get 2 threads per ray, 2 threads per pixel. And by doing that, you should be able to check the left and the right at the same time. And yeah, that should hopefully help with this. And the thing it also helps with is divergence. Because in 8x8 here, should we change this to 8x4 for a second and see if that helps? So, let me change that to a 4 there. That's made it even slower. So it seems like AMD hardware benefits. It must be doing it at wave 64 then. Or why would it? Yeah, but it's branchy code. I thought wave 64 would have been slower. Two waves, maybe it's wave 32. What happens if we did 16 by 16? Well, let's just do 32 by 32 or whatever. Right, okay, so 16 by 16. So you're not running them in lockstep at this point. But let's just see what that does. See if it changes the performance. That made it a bit faster. So it must be the caching. It must be able to cache, share cache or something like that. But it's a little bit faster. It's not massively faster. It's about 0.84. That's interesting. I doubt if you up this number, it gets better. Although we did 64. Ah, shoot. Got validation error, 64 is too big. Yeah, I don't do 32s is any better. It's actually slower again. 1.2 ms. Right. Okay, so that was interesting. So I reckon what we can do, if we launch, so yeah, I reckon we can lose the duplication. So we spend most of our time in the loop, right? We'll have to synchronize at the end here or something like that. But this should be fine, I reckon. Alright, so see how we can do this. So we did 8 by 8. Let's just do 8 by 8 still. What a fool that was. So right, so your dispatch index. So you want to share a pixel. So every even is probably the which one do we want to do? Yeah, I haven't kind of explained why it might be good to do 2 threads. Another reason why it might be to do 2 threads per ray as well. So the problem is right now is in a wave, you've got like a screen, right? And currently we're doing like an 8 pixels. Damn it. That was so close, it was looking so good. No it wasn't, it was off by 2. Right. Jobs are good. So by 4. So that's 32 threads, right? So the issue is these are all running in lockstep and processing the code together. On more different BVH nodes. No, that's the benefit of the BVH. Is the BVH, you can have your spheres like this, right? These two are in the same, these two are in the same, and you might have it like this. It's the benefit and downside of the BVH. So yeah, so the BVH nodes can overlap, but the spheres are only in one node, basically. So you have to make sure you traverse all the closer ones. Yeah, so in this case, you'd have to traverse both if you shot there, right? Basically. Yeah. So the problem is with this, right, is all of these threads, right? It's a lot of threads, right? So there's 8 of them by 4. They're all running in lockstep together, meaning if there's an if statement and like there's these if statements and say only one thread goes in there, that's a very bad example. So only one thread of all of these hits the left BVH. The rest of these will be idle, right? This is the worst case. The rest of these will be idle while this thread goes and does all this code, right? So you basically get, it's called, you get low wave occupancy, right? Your waves are they're not occupied. I think that's what it's called. So basically the proposal is this, right? Instead of doing each thread gets a pixel, why don't we just half it and do a 4 by 4, right? That way, if you'll get 2 threads instead that are still doing work, right? Instead of that one. But you know, say there's only 4 threads, or 4 threads that got in there. Instead, it'll be 8 threads, right? That's still running. They'll only be running for a single pixel though, but it's still more threads are being used. Now, here's the other thing as well: is you have an 8x8, right? Or 8x4. Chances are you have a sphere which does this, or whatever. Maybe a sphere or box, whatever it is, right? But it goes over like nearly half of your wave, right? The chances are a lot higher because it's wider. So therefore, these guys will all be active processing that I've hit the sphere and doing stuff, whereas these guys won't be doing that and maybe will be sleeping, right? So by halving this and sort of sharing the work, having 2 threads process a single pixel, it means we could hopefully reduce this divergence in these if statements that we have. So that's the hope, right? And also reduces the amount of code, because we're duplicating the code right now, the way we process it. But yeah, maybe there's a better way to process this without doing this sort of method. We should probably write that shader as well. But for now, let's just write it this way. So we got our coordinate. Well, that's kind of wrong now. So really the way we want to dispatch it is we want twice as much width. Is that right? No, okay, 8x4. Yes, it's 8x4, but we want twice as much width. To be dispatched. Okay. So basically, to work out our coordinate, it's actually divided by 2. Right, and we work out whether we're and we can work out whether we're a sort of like a even or odd thread as well. So, you know, we kind of process the same information, but it's kind of fine. Doesn't matter. At the start, it's just at the start. So we calculate the ray. Cool. So that's all pretty good, I think. So this is where it gets different. We work out whether we are, so I think we need to recompute this every time, because this probably sits inside, we don't want it to stay inside of a VGPR, I think, or VGPR. We don't want to waste a VGPR. So I think we'll recalculate it every time. I hope the compiler doesn't optimize it. So hopefully we can just do and1, and we just check if it's the even or odd one, right? So it's even. Which one do we want it to get? So even is right, left is odd, right? So I guess we'll just say, yeah. Well, yeah, I guess maybe we'll make it the other way around. I'm not sure. We could not it, but I don't know. Maybe this is fine. So maybe we'd say, hey, the node index is equal to that plus that, right? And that's our node that we're processing. But then we probably also want to know, yeah, what the sibling one is. We've got ways of working that out. But anyway, so that's our BVH index. Now it's simply, right, just this. BVH index. Get to that in a minute. So this is now just, hey, have we hit? Is it a hit? Right. So we can use wave intrinsics to sort of like transfer the data between the two threads in a bit. So this would just be BVH node. This should really be BVH node index. Let's sort that out. Right. Okay, so we just processed that one, right? So two threads will be coming in here together. That process the left and the right at the same time now, right? So if we've hit, yeah, this all stays the same. Okay. So now all of this code disappears, this right-hand side code, because it's just shared now between different threads. Right. So now this is where we've got to do some wave stuff, right? So what we've got to do is say, okay, if, now we do that check again. We kind of want to know if we are the, so we'll say, hey, if we're the odd thread, I don't think we do a check. Do we do? Oh, we've got to be careful. Wait, that's fine. Yeah, okay, it's fine. It's fine. So if we're the odd thread, we're going to do this sort of marshalling, shall we say? Right? We decide. Is that right? No. I think we just want to transfer it across. Wait a minute. Yeah, this stack is local. We could maybe share some of it. Yeah. So this is actually all in. This is all in the VGPRs, right? It's all local to the thread. It's not in shared memory. This sort of stack stuff. Oh, this could be a reason why it was running so slow. That check, we didn't remove it. Whoops. Oh well. We can add it in later. Too much improvement it makes. So basically we just want to transfer a few things. If we've hit the left, so if your buddy's been hit, so both you and your buddy have been hit, and then, oh my days, or if just one of you have been hit, yeah. So you essentially just want to do a read lane, but we need to work out our sort of like wave, our thread index, right? Our sort of thread index inside of a wave. So, oh yeah, it's easy. So you just want to get your sort of buddy. So we've done that before actually. What is it? It would just be an XOR, isn't it? I think so. Yes, you just want to get your sort of so your lane. Yeah, so you're gonna get your sort of like buddy thread index. So this is one that's working with you, right? So it's just the XOR of 1. So if you're odd, it's even. If it's even, it's odd. And then you want to read the hit result back. So is buddy hit? So you essentially do a read wave read thread. Let me get these intrinsics up. Read thread boolean. So we pass in the is hit, and our buddy. Yeah, so you pass in the boolean and the thread you're gonna read from, and then boom. So you get get your hit from the other thread. So now we can start to figure out this stuff, right? So we kind of want to know, so if you've both been hit, if is hit or is buddy hit together, then it's this more complicated one. But if I have just been hit, so you want your buddy to follow you though, right? So I think you need to work out which one of you is the left and which one of you is the right. And then just do this code here. Probably. BVH buddy node index. So there's your friends one. So that's just the opposite of that, right? So now you just want to translate this into explicitly left or right type of stuff. So you would just do billion. Well, there's a bunch of little bits of data you want to do, isn't it? So which way around is it? So if you're odd, then it would have been the right hand side, isn't it? So the left would be your buddy. And if not, is hit. So the right is just the other way around. Then we've still got this node index thing. BVH left index, BVH right. So in this case, it would be the yeah, so that would be that'd be your buddy's one, isn't it? BVH buddy node index, BVH node index. Cool, then it's the other way around. Right, so now would have got all the parameters back, and then this can just carry on both threads. Right, so there is a bit of extra communication here that has to happen now, but that's considerably like a lot less than before. Then this is all ran the same, although there is duplicate work, but it's the same amount of work that was running anyway. This is still ran as well. Right. Then calculate the next one. And then at the end, you only want to write if you are one of the threads, right? So one of the threads just goes, hey. So the thing is about the closest hit, you need to synchronize on the closest hit stuff, right? So you say, hey, have you found a hit? Yeah, now you need to synchronize at the end. So we've got a whole bunch of stuff, unfortunately. Maybe we can remove this near hit stuff just to test it out. But then it will kind of cheat with the performance actually, so let's not do that. So what we want to test, so we've got this sort of near miss, closest hit normal, and all that stuff. So you kind of basically just need to get the buddies versions of those, and then Although what sort of wave intrinsics do we get? Okay, we do get it across the vectors, fair play. So you basically just need to get all of that. Get your buddies. That found hit could kind of go, to be honest. So this was saying if the closest hit is less than infinity. And I think I did that in the wrong shader. Closest hit depth is less than infinity. Okay, so this is where we need to get the sort of the buddies versions of these, where it says record a macro, buddy, then it's just like wave read thread. Let's do F32. Let's call it buddy thread index. Go down. So we've got about 6 of those. 5 of those. Damn it. No. Oh, because it didn't have the damn. Right, I see the problem. It didn't have the initializer, so it got a bit confused. Sorry. Okay, so there's a kind of a few wave intrinsics here. We'll see how this goes. So it's times 3. This one is a times 3 as well. And this one here is a U32, U32. Right. So we just need to calculate buddy thread index. We can calculate that again. That. Right, so now we just effectively want to min our results. And I didn't write buddy at the beginning of these guys. So now I just want to min our results across all those things. Yeah, really we only really need to do it for the min for the depth. These can come in here. So really we just need to do this at first. And then we just do like effectively this equal min F32 this and buddy closest depth. So this, now that we've landed in here, you still need, yeah, I guess it could be done more elegantly after this, but let's just get it working. So basically what you want is you effectively want to get Min f32, this, and wait, is that true? You just want to copy the parameters all over because there's closest hit parameters and then there's hey Joe Mega, how's it going? How you been? So there's a closest hit and there's a near miss. So there's really only an if statement that we need to copy multiple parameters over. Yeah, so maybe we just need to say and the only one that really needs this is the main. No. So we need to say if yeah, so you need to read from the other thread. Yes, you read it from the other thread anyway. You need them both available. So if see, we've already kind of overwritten the value here, so I think we have to say it's equal to the buddies one, I guess. Then use the information from the buddy. So where's the, it's the hit normal, isn't it? It's these two, and the hit color. Say, closest hit normal is equal to the one for the other thread. And then this one is the closest hit color. Meh. What's up, man? Is it just the you just side or just the sort of cold weather, you know, the dark days. The usual. It's for our fair play. Yeah, it's quite tough at the moment anyway with just the bad weather and stuff. I find it affects me a bit. Yeah. Probably go outside some more, you know. But yeah. Did you get to work on that virtual file system stuff some more? Right, so we need to transition those for that case. Then there's the other case where you've got this sort of like your closest, your near miss depth of your buddy's one, right? And if that, oh my days. Yeah, so here we kind of want to put an if statement to say, hey, if, I don't know, sv dispatch index dot x is, just pick one of them. And then your other thread's going to go inactive, but that's fine because it's just at the end. All this can go, why is this here? Duplicate code. And then in this case, we can say, hey, if the buddy's near miss is closer than us, we'll copy it over. So all the near miss parameters. Oh. Hopefully this ends up better. And then we can write the pixel, right? Okay, so let's compile that. Tmin element. You need to know which one of you is the right hand side. You need the, where's your tmin? Tmin element. So you need to get your tmin element from the right hand side. Read thread F32 write tmin element. We're reading from buddy. Have fun figure out how to handle nested subsystems by zip in a zip or a tar GZ. Yeah, that's interesting. I'm not sure if I heard. The only time I've heard about that from, was it the WAD stuff? Was it that like the guy who made SDL, Ryan Gordon, sort of like, was it WAD? What was that sort of file system stuff he did? Maybe not. Sorry, WAD is the Doom stuff, isn't it? Maybe it comes from Doom. He did like pretty sure he did something. I guess he says he goes by Iculus, isn't it? But I swear he's done something where he's done like a virtual file system or something like that. I don't know. It escapes me. But yeah, maybe it comes from Doom or something, where they allow to layer mods on top of each other and stuff. But where it comes from. Yeah, I think that's alright. Right, it compiles. We've got to remember this if statement here, which actually does the speed up with the traversal and avoid you searching the whole damn tree. That's kind of the reason why it was probably slower. Probably far slower than the tile binning. Right, so we're doing 2 threads at a time now, so let's just double check and make sure it's all good. So we're launching 8x4 still, but it's doing a 4x4 quad instead of a 8x4. So we launched 2 times extra on the width, and in doing so, we divide by 2 to get the actual pixel, right? Then this is all basically shared between 2 threads. They're just running the same code. It just doesn't matter. It's fine. But the beauty is here when we get into this loop, because we basically just say, hey, if you're the odd guy, you get the right-hand side node. If not, you get the left-hand side node. Right, you process the left and right of the binary tree or the siblings at the same time. Right. Yeah, so nothing. It was just these things that were different, and they're fine now. And then after you've done that, you need to sort of synchronize and sort of read a couple of things over, like a boolean save your friend here, and if you're, in the right hand side t min, and then you can sort of work out this stuff. This stuff we need to double check, right? So it's the right hand side if it's odd, right? So the left is, so if it's true, then it's the buddy that's the left. If not the right, it's the opposite of that. Fantastic. Buddy is the left. Yep. If not, it's the opposite. Excellent. So then we just do the standard stuff which we did before. Each thread has the same information to work off of now, like if the left or right hit, and which ones to look at from now. Cool. This code, we didn't check it. Yeah, let's go back up the stack. All good. Right, now it's code at the end. We've traversed everything. We get the other thread's thread index, so we can read the closest hit. We min it. If any of the two threads hit, we go into here, we sort of read the friend's values, and then we say, okay, if you're the right hand side thread, then basically just grab the values which make sense. So which ones, grab the min depth basically. Values, and work with that. You should actually get 2 layers of anti-aliasing as well. Oh no you won't. It's 1 layer. Still. But you'd have 2 layers which you could work with. That's interesting. That's an interesting hack. We could extend that to work with 2. If there's 2 different near misses, you could technically do this twice with this method. That's cool. So the anti-aliasing will work even better. tar GZ and stuff like that is very interesting because while tar is inside the GZ, it's an actual file that contains a file that contains a pseudo subsystem. File system, yeah. Yeah, tar's really elegant and simple. I like the, yeah, and then it's just a zip compress on top of that, isn't it? So you zip decompress it, and then into another chunk of memory. So I'm wondering, do you have to, so as soon as someone accesses something, you basically just decrypt the whole, you basically decompress the whole thing into memory, right? The whole file into memory. You can say you archive a tape drive. But yeah, I like the microtar library. It just sort of shows how, by Mr. RXI. It just shows how sort of simple it is. Like, and also how simple Mr. RXI makes his code as well. Like, literally that's 100 lines of header, and you can access a tar file. Open, you can read and write from it. I think it's like 400, 500 lines of code in the implementation. Yeah, less than 400 lines of code and boom, easy. I did not realize it was that simple, but it kind of makes sense, right? It's literally just a block of memory where you've just got a header and then the file contents. So, I'm not sure why you'd want to overcomplicate it, but people could probably overcomplicate it, right? All right, so let's see if this blows up the computer. All right, if the stream goes down, I'll be right back, but let's see. Shoot. Right, we should be back. Says it's unstable. What? We'll have. There we go. Thank you, thank you. So, why did it crash? Let's investigate. So it could be because we're writing out to the wrong pixel location, but I don't know. We're still using ucoord. Ugh, right. Something sketchy. Let's have a look. So we'll look at all of our indexes and stuff like that, you know, into buffers. It could be an infinite loop, but I doubt it. But let's just double check, right? So you got this. Let's divide by 2 now. That's the difference. So you're launching. Let's just double check our launching thing makes sense. Right, catch you not so red. Thank you, sir. Have a good next couple of days, and maybe see you Thursday. If not, have a good rest of your week. Catch you later, buddy. So we're doing this sort of like ×2 display width, divide round up 8, right? Because we need an extra. Doesn't make any sense. Eight by 4. So there's 2 threads. So technically it's a 4 by 4. So we need 2 width on that. That makes sense. Makes sense. But anyway, if it goes out of bounds, it would fail, right? So let's see it any more times as dispatch index is used. It's used here to check if we're even or odd. Even or odd, right? Type of stuff. And that's it. It's not really used anywhere else. So let's keep going. So where else? So we've got the infinite loop, right? Possibility. Yeah, so this just ends it with 1 and gets 0 or 1 back and just adds it, right? So no problems there. So you're going down here. Base, sphere index, node index, that's all fine. That's the only place we read from the buffer. So where you calculate the next. Oh, that's a problem. Your buddy thread index is not that. What you want is the local index. Right, so really where we're doing a lot of this dispatch index stuff, we should technically be using that local index, I reckon. Because yeah, it's technically still fine, but it just it's technically still fine. But I think it's more readable that way. Right, so let's read what was going on. So we was using the full-on dispatch index, which would have meant like a pixel coordinate or something, right? And then we would have been using that on something which should only be from 0 to 31, and it would have gone out of bounds there. I'm not sure what it would have done. It maybe would have like it maybe would have done like a bitwise and sort of just use the low bits internally, and then it probably just would have returned that. It maybe like overflows basically. but we don't know. So because of that, this information could have been wrong, and they would have acted on that wrong here and produced a different next index, which could have made like an infinite loop or something like that. But something we've got to be aware of is we could actually be... No, it's fine. I just thought we could be making an infinite loop, but we're not. Right, so let's just double check it line by line. So we just XOR that, get the buddy thread index, read the isHit boolean from the other thread, calculate our node index that the buddy was reading from. It's just the same expression but with a not on it from above. Read the t min. That's wrong. That's wrong. That wouldn't have caused us a problem though. That would have been a buddy t min. And the right t min. T min element. Buddy t min. So I'm thinking to let the subsystem handle it, so it just gives more controlled stuff like the zip compression subsystem, handle things like included tar, and relies on the implementation to be in every single subsystem. So probably going to go for the try paths inside. It returns, and then like a handle. The visual files from there. I'll just try match the file name. I'll match the file name without the extension of. Right. Yeah. Yeah, it's interesting. I'm not sure. Like, how would... Like, if you were to, sort of like mount this zip file, like, do you just decompress the whole zip file and put it into memory? Or is there a way to partially decompress the file? Yeah. Right, so let's double check this stuff. So this was fine, right? This meant it was the right hand side, so the buddy would have been the left. Yep. Yeah, this is all fine. So you've got your left and right index now. You can set the next one up. Good. All pretty fine to me. Maybe we should share some of this in LDS. I'm not really sure. Save a few VGPRs. Right, so I think that's fine. Let's just double check this. Yeah, so this would have all been wrong information as well, but I doubt it would have caused any problems. Well, yeah, it should be fine. Right, just a single thread is going to write. All good. Right, so let's give that a go. So hopefully the stream doesn't crash again. Zip would have a file system Zip should have a file system outside of the compressed chunks, to the point that the files in the zip can be compressed with different algorithms. Right, I see. So a tar file is like, it's a compression of the whole package, whereas a zip file is like you've got packages inside it that are individually encrypted, right? Okay, I didn't know that. That's cool. Right, the computer could blow up again. So yeah, the stream dies, I'll be right back, but hopefully not. Right, let's try this one out again. Right, so something else is fishy now. So we'll rethink what is going on and what could be the problem. We could comment code out, right? And then just, you know, try and figure out when it crashes and stuff like that. But then we'll be basically rebooting a whole ton, which would be really dumb. We've got to try and think of what's happening. Yeah, keep trying so it doesn't crash. That would be really painful. I can't believe this AMD problem is just so silly. Like, so what we changed is we just made two threads process the same pixel, right? That's what we changed. So we can make it traverse the first loop and then check if it crashes. That's one way. But we're not going to hit anything anyway, so it won't render anything. It would be pointless. So shaders. Right, where's this thing happening, huh? So we're launching twice. Okay, they're bracketed. Good. Twice as much along the width. Because you're taking two to do a single pixel, right? There's nothing wrong with that. 8x4, that's fine. Nothing's changed there. It's all been within the shader code, right? Other than that. So your coordinate then is just that divided by 2. Is that right? Yeah, because then, you know, it would truncate. Right, so every odd will land on the same one, which means 2 threads will share the same coordinate, right? Makes sense. So this stuff I think is all fine. Here. We're literally just ANDing it with 1. Like, hmm. Um, hmm. Yeah, so if we're the odd thread, then process the right hand side node. Let's see where this goes. So this indexes into there. Get that out. Ooh. Hmm. We didn't really change much. We just reduced the amount. We just, you know, reduce the duplicate code. What is a Jedi's least favorite coding language? JavaScript. Nice one. Brunz. Hey there, welcome random. How's it going? Hey, how you doing? Uh, they're processing the same pixel. You process the left and right together. Your even and odd threads process the different ones, right? They process the different ones. Let's get Milton out and do some drawing. I don't know where the bot did. I've only got like C in there and C++, C++, Rust, and Zig, I think. I don't know what ones I got. Very few though. Awesome, good to hear. I'm not doing bad. Not doing bad. Bit tired, but you made some good progress today at least. We're just trying to figure out why my GPU is crashing. So we've got a bit of an issue happening. But yeah. We're trying to see if we can process this faster by doing 2 threads on a single pixel, but we'll see. Yeah, C++ will get you. And Rust. Hmm. Hmm. Interesting. Yeah, but I think there's a cooldown on it as well. A brief cooldown. Yeah. Or maybe it doesn't do it all the time. Hmm. So we start doing the things here. You know, all the threads in the wave are running. Now you're reading from your active thread, right? You do have this where you go out of bounds, if so don't write anything. Right. But you've got two threads, you only be reading from your buddy's thread, right? So oh my days. The thread index was all wrong. I didn't multiply it by the y, did I? So it's SV is this, right? Damn it. Y times so the width is 8, right? Plus this. So that could be the problem. We're reading the wrong thread, getting the wrong data. Not sure though. Well, if you're getting the wrong data, then it means you're probably traversing wrong. You're getting it wrong. I'm not sure why it would go out of bounds though. We'll see. Let's think about that. So if that was wrong, you're just getting the low ones. You could have been reading an inactive lane, and there might have been garbage data maybe, right? That could possibly be the problem. All right, this is looking like good. So is that right then? So it's y, whatever the y is times by 8, because it's 8 across. And then you're XORing X to get the other guy. Okay. So any other time you use local index, what are you doing with it? Are you doing any of this stuff? So that's just sort of the odd or even thread, which is fine. Yeah, it's all fine. Right. But this seems like a good thing to test. Right, let's try that out. If the stream dies, I'll be right back. Let's go. Right, we're back. Let's try this one again. Just when you think you found the problem. So what do we use? It's always U chord, isn't it? Pretty fine. Twice as many X's. Two seems fine to me. What? Got some almost text. Yeah, what does glyphs doing in GPU memory? Okay, it's probably some other application, isn't it? I don't have... Weird. Yes, some of the tiles are fine. Ooh. The dispatch index is not even used much, it's just here. All makes sense to me. Yeah, because it says puzzle. Yes, that's fine. See, we could just min. We could play it safe, right? We could stop it from going too far, then every time we index, we min, right? I think this could be a way that we could solve. We basically bounds check it, right? But we clamp it. We bounds clamp it. For everything. And we even the loops, right? So you just say, okay, we'll make sure. And you know, maybe you have like a number of iterations. Number of iterations is less than, I don't know, maybe you've got, let's just say 1024, right? So you do that, you basically min with SV BVH, sorry, BC, something like that. So you just clamp that. And then also you clamp when you do spheres. These spheres are obviously clamped, right? Because we clamp it here. We clamp it there, so that's already fine. This is another index. We're only up in that by 1, but it's probably worth looking at anyway. We shouldn't hit that. Well, it's not 32, it's technically it's 31. It's inclusive, isn't it? Yeah, whoops. Gonna chase that around. Technically, this is min take 1. Good point. Okay. So any more of these guys we'll look out for. Right, so that seems like all the array indices. There's one more final thing, and that is the store texture, right? That's going to be inbounds though. We've guaranteed it up above. And the top check. Right here. If it's out of bounds, bail. Okay, so that seems like... I think we're doing the best we can there. Right, so hopefully it doesn't crash. If not, I'll be right back again. Damn it, it's completely screwed my intelligence. Okay, so we're running. The sphere ray tracer is bloody slow. So it's probably hitting the max iterations. And this is not running. So you got to remember the ray tracer tiled is still running. The old tiled one is still going. So really if we disable the tiled one, right, what you'll probably see is nothing or glitching. Right, absolutely nothing's been rendered. Horrible. Right, so clearly with infinite looping, right, if I was to bring this down to maybe 64, with hitting 4 milliseconds here, if I was to up that to back to the 1024 again, we're getting 16 milliseconds. So clearly, we're infinite looping. So how can we test this? Well, we can literally just pick a pixel and print. So let's just go to, let's cap it to 16, so it finishes quicker. And we're literally just going to print stuff out. So we just say, okay, so we pick a pixel, we should get two things printing out. So we'll just pick halfway through the screen. So let's just pick 333. Oh, that's not JavaScript, what we did. And equal .y. Then we'll just print out GPU hprintf. So print out equal wait, what do we want to print? Should we just print out the BVH node index? Okay, that was something nice to see. Okay, so we're actually seeing multiple on the same coordinate. This could be a problem. Why? Why are we seeing multiple on the same coordinate? Oh, sorry, multiple iterations. That's fine. That is fine. So the first time, right. So sometimes they're sensible, and other times they just go pure crazy. So on the first iteration, you've got 1, 2, then 3, 4, then 3, 4 again on the third iteration. That's not right. So, and then here we did 1, 2, 3, 4, 3, 4, 3, 4, 3, 4. So we just keep hitting the same node for some reason. That's given us a clue on what's going on. Right, so next BVH index is not being set to something sensible. So if we read our buddy, so we should really go down to here now and print out more stuff. Like, what do we want to see though? That's the question, right? So we want to see, hey, what is my left and right? You probably say, hey, what is the left? What is the right? Does this get mutated? No. So as it is there, that's fine. Buddies one. Yeah, so let's do the print again. And this print stuff is so handy. I'm not sure how I would program this without print. Just bananas. Pure bananas. But I'm getting GPU crashes though, so part of me would be like, I wonder how I would have programmed it without crashing. But anyway, left, right. Okay, so this should hopefully help us more. And then we can get the child information as well. You know, let's just do it at the same time. We'll just get the left of the right, you know, that sort of thing. Right, so we'll just see what we're getting and why it's misbehaving. Okay, here we go. Right. So here's where it happens. So first iteration, you've got left and right 1. What? Left and right have the same 1? Why is that? But the way the threads get assigned not even. Like they're not. Should we get our wave in? Should we print out our wave index as well? Thread index, right? Your wave thread index is so your one. It's just that. The wave thread index is 3 and 4. They are different. But what's happening is the left and right end up in the same node for some reason. Ends up being 3 and 4, which means it must be right. Let's print out these two guys. So we'll just say me and buddy. So node index and buddy node in BVH buddy node index. Print that out. Yeah, so me and buddy, we got different guys, right? 3 and 4 here on the node indices. Right? So why then is left and right equal to 1? Is something up with my ternary operator in my compiler to cause this? Like, what is the problem? Is something up with the ternary operator? Because it's not doing it right. So we can debug this. It's got to whack out the compiler. Cat. Alright, which one do I want? This guy. Right, okay. Anyway, and then I need to say dash dash debug AST or something. Okay, so it just dumps the whole AST. Well, it tries. Clearly we'll run out of... Ah, no. Well, I tried. Let's debug print the abstract machine. No, it's probably a bit too low level, actually. Crap. Got an unhandled type as well. Fair play, same one. Well, that ain't happening. So the other way to debug this then is just, you know, let's just do an if statement. So we just say, so instead of doing this, okay, just do if. So they both got set to 1. Like these are 3 and 4, but they're not even 1. No, I can't use GDB because the problem is this is GPU code, right? This runs on the GPU. So I've got a little custom compiler that compiles C to SPIR-V, and you don't get debuggers on GPU. And you don't even get printing on GPU. But thanks to the compiler I've written, we get printing at least. Basically. Yeah, it's pretty shit. Sorry for my French. GPU program is pretty bad. Tools that they're horrendous. Alright. Give that a launch, see what we get. Yeah, Renadog has a debugger, I guess, but it's... Yeah, it's an interpreter, isn't it? But I think it only works... Does it work on the... Does it work on the source code level? And sometimes it doesn't have all the values. Sometimes. I don't know, I remember trying it out before. It was still kind of early days, but maybe it's got better. Right, left and right are still 1. What am I experiencing right now? So we've got these guys. Which run through here and they're 3 and 4. Me and Buddy, or 4 and 3. Then left and right are 1. Oh, they're booleans. Damn it. Implicit cast. Crap. That's the right bugger, isn't it? You can even debug source on AMD. That's pretty sweet. That's noisy as crap, but it's working, kinda. Right, it's still not fully working. But it's getting there. I'm not sure what the problem is though. Is it the number of iterations? No. Clearly not that. Shoot. Confusion has a disclaimer, this feature is highly experimental. Right, okay. Fair play. And do their own debugger, yeah. Nice. But yeah. Yeah. I think I need to try it again. Problem is I can't decompile it to C. It has to decompile to something else. This is going from Spear V. Archived. Dun dun dun. Alright, so what else could be wrong now? So you got me and Buddy, left, right, left, right. Is the left is, and the right is even, isn't it? Yeah, that's the way it works. This is, yeah, this is fine. Right, this seems to be traversing fine. It's getting bloody noisy though. So where's all this printing code? Let's get rid of the print code. It's actually running like even slower. Still to MS. It's running like slower. I wonder what the problem is. Are we hitting max iterations? Should we up that number and see? We're not hitting max iterations anymore. Oh boy. Right, so it turns out this is probably not as good as what we had it at anyway. Like, was getting like easily twice the performance. And this would probably make it do better. They made it slower. I'm confused. Right. So it could be at the end the way we're doing this sort of stuff. I really don't know. So you get your buddy thread. You read from the buddy thread the closest hit. Min that. Then if we get a hit, both of the two threads go into here. Then you access from the buddy thread all of this stuff. And if you're one of the two threads, you come into here and you can write out a pixel. At least that's the idea. See, I wonder how much of it this is. We should probably turn off the T as well and see how noisy it is. Turn off the time. Right, so it's still pretty noisy. If we put this back on. Just makes it even more noisy. So you got two threads processing the same pixel. Then they must have hit different boxes. or something like that. Right. Yeah, it could be earlying out. Right. This is the problem. I know the problem is now. The issue is your thread is inactive when it reaches here. So it's reading garbage or something like this. Yeah, so is that right? Is running. Yeah. So you basically have to keep running. Yeah, this is probably not a good solution. Yeah, so what happens is one of your sort of pair of threads sets this running to false, right? And then it just doesn't. Yeah. Then it becomes inactive, and then you do a read lane, and it doesn't work anymore. Right, but I don't know if that is the reason why. Like, why is it so slow? Is it because it's trying to keep going longer than it should do? I still think it could be keep going longer than it should do, though. I wonder if there's a way to sort of like. So the is running, if you just kept it going, it's just going to do min order checks and. No, 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 no. That shouldn't be the problem. They should be hitting the same boxes always and traversing the same tree. You do two threads of processing just. Yeah. What we're working on now. We're just trying to. We're trying to. Today we've written a BVH traversal for rendering the spheres. We did have it working, but we tried to write it in this sort of different way to try and optimize it. Where we've got two threads processing a different BVH node at the same time. So essentially, two threads write a single pixel and they go down the tree together. They process the left and right at the same time. Then they go down and process the left and right at the same time and do the same. And then, yeah, process the spheres as well. To try and reduce the divergence. But it's ended up being slower and it's got some glitches. So I'm trying to fix the glitches to see if that's the issue or not. I'm not sure what the flickering is. We're not to test, but I think this should be it to handle nested subsystems using a closure that does the actual specific job it needs to do. Sweet, let's take a gander. Recursive subsystem. Trial subsystems. Right, then you call yourself again, right? Right, so okay, so you're merging. Right, to merge the... This isn't a file, we can't continue. Oh, right, I see. So it's to find a file using the different subsystems. Should handle zip in a zip in a zip, etc. Fair play. Right. Okay, I see. Awesome. Couldn't you... Yeah, you wouldn't want to do that though, isn't it? Yeah, I guess it depends if you want to make this mutable at runtime or not. Because ideally, well, when you boot up the application, if it's fixed, you could just sort of basically just, flatten. You could pre-resolve that and not have to do it every time you do the check, right? Yeah, awesome. Um, right, so why? So I think we're processing two at the same time. Yeah, so we go down. Yeah, I think we're going down the same tree for the pair of threads. I don't think there's any divergence happening there, right? Because they're both figuring out like which one is the left and right, and they both keep the same stack, right? And they both traverse the stack in the same way. They both traverse the stack in the same way. That will make sense. Yeah, I can't think if it's going to be inactive or not. It should be fine. Let's bring back these if statements and look at it. Yeah, so these are never going to diverge. Like we're seeing it here, they're printing out two at a time always when they go through this loop. We go over all their iterations and then they just stop. So it's not the fact that that the threads are diverging for the single pixel. So it could just be the thing at the end. But I'm not sure. So you read your buddy's closest depth. Let's move this stuff out of the loop, outside the if statement. They should be both going in there though. Yeah, it doesn't change. And just thought of something to prevent a file having to be opened twice. Check if the subsystems already exist for a given path. That's a good point. Yeah, that one too. Oh. Near miss, bring them all in. There's 3 near miss ones. Yep, that's fine. There's 2 of those. Before closest depth, something like that. Right, that fixed it. The equal operator wasn't right. It wasn't working for some reason on the floating point, even though we did a min. Super weird. It didn't like it. Anyway, okay, so let's remove the printing code and let's just verify our suspicion. So that went down 24. That went over 24 iterations. Kind of makes sense, I guess. Okay, so it's about 2.3 ms. That's really bad. So it's actually even slower having two threads process a single pixel. At the same time. So what happens if we increase the... There's not really much we can do, I don't think. We can remove this and, you know, if it... No. Yeah. Well, it was okay. It's basically twice as slow. That's what we can guarantee. It's basically twice as slow because I remember when we did an 8x4, right? We didn't do 2 threads per pixel. It was about 1 point something ms, right? But now it's about 2.3 ms, right? So it actually is twice slow. We did an 8x8, it went under. So let's change that. For GPU loop stuff like that, Phil, you should follow the NASA rule and max the on possible infinite loop. Yeah, it's probably a good idea. Especially when I got this GPU crash, I should probably do it all the time. Really. I should probably bounce check all my ray indices as well, just in case. Then it should stop the stream going down. Yeah. And then I can remove it later or something. Yeah, so we changed that to an 8. So that was quicker apparently. Yeah, so that's brought down to about 1.3 ms. That's still slower. It was about 0.8 ms before. And you know, we upped it to 16 and it got a bit better. Probably because of sharing cache on the compute unit or something like that. That's what I was thinking, at least. No, this one actually got a bit worse. And it actually got a bit fuzzy. For some reason. Oh, because it's using local index to work out the wave. That's why. That's fine. But anyway, we know it's worse. Okay, so what we'll probably do is I'll probably like remove these git chain, like I'll probably revert those two files. So the thing we should try next. Is try to see how we can basically keep this kind of loop. No, perhaps I'll keep this actually. I might keep it. But I'll just revert this sort of stuff. But what I think we should do is still sort of only have one node per loop iteration, but we'll or something like this. I'm not sure exactly, but we need to find a way to speed it up. I'll reduce the amount of code or something that we're putting in here because we was duplicating the code. We'll find a way to not duplicate the code anymore. We'll probably just put a for loop in there. Yeah, I think we'll just put a for loop in here to go over the left and the right node. And we'll probably have a constant that comes from the CPU side so it can't unroll it and optimize it. Because otherwise it'll just unroll a lot of code, you see. Yeah, then we'll see if we can optimize it any further. Then after that, we'll look into how we could probably optimize the tree itself and change. Whoops. Because this tree here is probably not the most optimized, right? So we'll see if we can what we can do there. Or maybe increase the number of spheres and see how it compares to the old tiled one with more spheres, right? All that sort of stuff. Right. I think I've got to get going now, but I'll be on next on Thursday at 8 PM GMT. And we'll spend a couple hours just seeing if we can basically revert this back as we said, right? But try and keep it from duplicating code and see if that's any better. That'd be cool. Right, let's find someone to raid. No, there's no one. Guess I can just raid Primogen or something. Right. So have a good rest of your week, everyone. I'll see you all on Thursday. If not, I'll be on Sunday. Yeah, I'll post stuff on Twitter sometimes. Discord if you come and hang out. That's about it. Right, thanks everyone. Catch you later.